So here is section 4.2, exercise 24. And in exercise 24, they want us to get the formula for this summation and then use that to evaluate for n equals 10, 100, 1,000, and 10,000. So in 24, we have the sum I equals 1 to n of 2i cubed minus 3i divided by n to the fourth. And again, this is very similar to problem 20, which at the end I said was problem 10, but hey, you knew where we were. So this is 2 times the sum of the I cubed from I equals 1 to n, and then minus, well, let's see, and we've got n over n to the 1 over n to the fourth here times everything, so I'm just going to put the n to the fourth down there. And then 3 minus 3 sum of the i's, I equals 1 to n. Okay, so this first sum, we have 2, and then that was n squared times n plus 1 squared, all over 4. And then minus, we had 3, and that's n times n plus 1 over 2. And then that was all over n to the fourth. So this becomes just kind of an algebra exercise. That 2 and that 4 make a 2. So I've got a common denominator here. I can take that down here with the n to the fourth. And then here, notice I have an n times n plus 1, and here I have an n times n plus 1, that whole thing squared. So I can take out n times n plus 1. And what I'm left with, and I've got the 2, and I've got the n to the fourth, and what I'm left with all that was I took out that 2, I took out an n times n plus 1, so I'm left with n times n plus 1. And then here in this term on the right, I'm just left with the minus 3. And so I can get rid of one of these n's here. So at this point I have n plus 1 over 2n cubed. And then on the inside I have n squared plus n minus 3. Now that, I think that, does that factor into, yeah, that factors into n plus 3 times n minus 2. No, it doesn't. Never mind. Yeah, I don't think that factors very nicely. So, that's our formula. And it says, oh, okay, evaluate that for 10 and 1,000 and so forth. Well, I mean, at this point, to evaluate it at those numbers, again, I would just probably put it in something like Desmos or something like that. I don't know. What about 10? Let's see. N equals 10. That implies what? We get 11 over 2 times 10 cubed times 10 squared plus 10 minus 3. And so that's 11 times, let's see, 110 minus 3, that's 107, divided by 2,000. And it's like, okay, well, so, I put that into a calculator and I check it out. So here's the thing, though. We could do this with Desmos. I didn't do this ahead of time, so it'll take me a moment as we get there. But actually, well, we're in Sage, so let's start there. with Sage. Okay, I have J, but now I'm going to toss in here comma N. Okay, so I have that, and then now my sum is really close to this. It is 2 of these, so there's a 2, and I need my asterisk for this thing. So 2 times j cubed minus 3j. So back that up and get a 3 in there. And now this goes from 1 to n. So let's get an n in there. So S is now this, and this doesn't make much sense, numerical S. So for a moment, let's leave that out, and let's see how this did. So I just told it 1 to n, but I made n a symbolic variable. There we have it, and so let's evaluate that, see if we did okay. Looks like it. And we have 1/2 n to the 4th plus n cubed minus n squared minus 3 has n. Okay, well, let's go back and look if that looks like what we probably got. So we go back here. Oh, I forgot my n to the 4th. Okay, because I was thinking, no, heck, that's not at all what we got here. Okay, let's go back. Forgot my n to the 4th and all that thing. So we come back, right? I had to go in here and I have to divide by n to the 4th. So I'll put in a parenthesis around that whole thing and divide by n to the 4th. Okay, now let's try that again, evaluate, and what's it say? That's looking a little better. Okay, so we've got an n cubed over a 2n cubed to start with. Let's now go back and kind of see what we have here. Yeah, right? So there's my 2n cubed. When I multiply through by the n plus 1, let's move down here a little bit. So I've got the 2n cubed on the bottom. Well, on top, multiply through by n, so I get my n squared plus, n cubed plus n squared minus 3n. Multiply through by the 1, I get plus n squared plus n minus 3. And so I've got n cubed, that's good, 2n squared minus 2n and minus 3 all over 2n cubed. Okay, I believe that is what Sage was telling us. Yep. And so, there it is. And then I can evaluate it for 10 and so forth. So let's just show, I could assign it to something first, but we'll just do show. And what we want to show is S and dot subs, so we want to substitute. Again, open parenthesis. What do we want to substitute? Well, we want to substitute n equals 2 equal signs 10, and close that and close our show. Now the spaces, I think it'll take the spaces in the parentheses. Usually I get rid of them, but again, this is just trying to get this done a little quicker. So let's see if this worked. And there it is. 1177 over 2000. Is that what we, well, we knew it was over 2000. I don't know that we came up with the 1177, right? We had 11 times 107. Well, 11 times 100 is 1100, and then 11 times the 7 is 77. So sure enough, right, we got that same thing. So that was with Sage. Again, we could plug this into Sage or Desmos and evaluate it for all these different numbers. Let's go to Desmos, and again, you know, so let's try to put this sum in, but Desmos doesn't like that n there, so we're going to have to be a little trickier about it. Let me get rid of that. This is the old stuff, but it was very similar. So again, that needs to be a 2. That one needs to be a 3. And then we need to divide the whole thing by n to the 4th. So divide n okay, back to the symbols, to the 4th, and then we'll add the slider n, and I can just make it 10, and it says it is 21.0275. I don't know. I'm not sure if that sounds right. Make sure I put this in. Oh, look, I was going to 25. I need to put, whoops. Come on. I need to get rid of that 25. This is a problem when you use old stuff and don't start from scratch. You can forget to change things. So that looks a little better. Okay, and it says if n equals 10, we get 0.5885. Sounds about right. What was it? It was 1177 divided by 2000. And there we go. 0.5885. So same answer. Okay, and we were able to do it this way, and then, you know, just very quickly I can you know, add another 0 here, get that evaluated numerically that way, 0.5089. Now in Sage it'll be interesting, because if I go in there and add another 0 and then evaluate, probably going to get a really big looking fraction. We'll see here. Yeah, so you know, you get this fraction, which again, well, it's a little more than 1,000 over or, well, no, not 1,000, 1 million over 2 million, so it's about a half, which is kind of what we got. Okay, so we can evaluate these things using the Sage Math Cell pretty simply, and also with Desmos. Now, what's really nice back here with the Sage Cell, right, is we could do this summation up to n and actually get the formula, you know, so the formula is right there. So that's pretty neat. Again, this is where, you know, technology, the algebra, you need to know some algebra. If you don't know any algebra, you're going to have big problems. But as long as you know some algebra, you get the idea of what's going on here, and as you work with such things, you get better at it. But in the end, the technology will do the algebra for us. And as long as we put things in correctly, it will do it right. But you see, this is where, you know, again, I got that answer of like 21, and I thought, hey, wait a minute, that doesn't sound right at all. I mean, you have to have some idea of what the heck it is you're doing, and you you know, and then I realized, oh yeah, I hadn't changed the 25 to an N. Okay, so that was number 24.